A very good evening to all present here, guys. I welcome you all to the session. I believe everyone is doing great and everything's been fine. So let's just get started with our sessions. So yesterday we actually saw what are the different types of machine learning algorithms, like what is supervised, what is unsupervised, and then I also gave you an example of what is a classification and what is a regression. So we basically saw all of those stuffs, right? So now the next thing what we are looking on, what we are looking to target is how to deal with linear regression. Okay, how basically we can proceed further with linear regression. Sorry. Yeah. How to proceed further with linear regression and what exactly happens at the back end of linear regression. So this is what we need to understand from today's session. Okay. So if you have any queries from the previous session, you can just ask me right now, and then after that I can start with the today's session. So if you have any queries regarding to the previous session, please ask me right away. Yes, people, please tell me if you have any doubts or any concerns. Please let me know right away so that we can start it with today's topic. Kind of, yeah, it's going to be an issue because yesterday was the basic one and you really require a strong basics to understand what we're going to learn today. But you can try it out. You can stay in the session. You can try to understand what is happening. And after the session, you can go to LMS portal and the video will be uploaded there. You can rewatch the complete sessions again, like yesterday's session and today's session both. Okay. Yeah, Mayank, I'm going to do that. Don't worry. Okay. Let's just get started with this. And then the moment when we jump into the practical side, I'll definitely do that, Mayank. Okay. I do that on a usual basis. No issues. Okay. Fine, Mohammed Hassan is the same thing. Okay. Okay, so let's just get started with this. Yeah, so the people those who are attending the session for the first time today, guys, you might get confused, okay, because obviously we have covered some very basic stuff yesterday, so you need to know those basics, but it's okay. You can stay here and here, you can try to understand what we're going through, and then once we're done with the session tonight or tomorrow, maybe whatever the time you're comfortable with, you can just go through the LMS portals where both the videos will be uploaded, and then you have to watch these videos again. See, guys, sometimes I can understand, like, life is busy, you might miss some sessions. It's okay, no problem. But the thing is, guys, you have those recordings on LMS. So before attending the next session, my advice for you guys would be first go through the sessions, like what have you completed in the previous session before attending a fresh session if you were absent in the previous session, because it will save the time for both of us. Okay, and it will go smoothly for both of us. So that is the reason why I ask you guys to do this. Okay, yesterday's video is still not uploaded. Okay, fine. I'll talk to the team and I'll ask them to upload it soon. Okay, thanks for letting me know, getting to know this thing. I'll talk to them. Okay. Yeah. So let's just get started with this. So yesterday, guys, I've shown you like what is linear regression, right? So in this linear regression, guys, you saw there are some data points and we were basically finding some best fit line. So how do you actually get that best fit line? So we need to understand that. Okay, how exactly do we find that best fit line? So this is basically, let's just assume this is our best fit line. Okay, on a random basis, we just consider this a best fit line on a random basis. Okay, and now these are our data points. Now what we do is we basically calculate the distance from these points to these lines. We basically calculate the distance of these points to these lines basically. So draw a perpendicular line with respect to y-axis and then calculate the total distance. So what is the total distance here, guys? This is 3. Let's say this is 3.5 and let's say this is 5. Okay, 3, 3.5 and 5. So what is the total error now? Yeah, this is what the error we call it as, because this is far away from your best fit line, right? Our aim is to get a best fit line in such a way that we need a very minimal error. Correct? I told you, right? Our line should pass through all these lines. If it is not possible, then it should pass in such a way that the error is very minimal. That's what we need to do. Okay. So yeah, what is the error in this situation, guys? Let's draw a line here. This is our total error line. So 3, 3.5 and then 5. So what is the total error? What is the total error, guys? Please calculate and let me know, everyone. Yeah, the total error is 11.5 here. 3 plus 3.5, 6.5, 6.55. It gives you 11.5. Okay. So now you get to know that with this kind of placement, our line is giving us the error of 11.5. So where do we go next? Do we go above or do we go down, or we don't know? Like our model doesn't know where it should go, whether it should go above, downwards. Okay. Or does our model know that it has to go downwards or above? Yeah, our model actually doesn't know whether it has to go above or downwards, right? Yeah, trial and error method. That's what we are going to do. Okay, trial and error method. Yeah, we basically have to go with trial and error method. So let's say we just go downwards. Okay, let's say we go downwards. So this is what I have already explained you, and here it goes downwards. So this one is 8.5. What is the error we have received? 11.5, right? Yeah. Now this is your best fit line. Now what we do? We again calculate the distances of these points to this line. And what is the distance here, guys? What is the distance we have got here? Let's say this is 3 now. This is 3.5, and this is 6. So what is the total error? Yeah, this is even increasing. This is not actually 12.5. It will be more. I've considered 3 here. Instead, I should have considered 4 and 4.5. Anyway, it's okay. No problem. So let's say this is again 12.5. So now your model knows that if it goes below, then it's going to increase the error. So it's not going to go below. Rather, it's going to go upwards. So how much upwards is it going to go? Let's say this was our previous line of 11.5. Right? This is our previous line of 11.5. So with 11.5 error, I mean, with this line, we have got 11.5 of error. So we will try to reduce the error now, right? So we will go even above this line. The next iteration for your model would be above this line, because until this line, he knows that the error will be more than 11.5. So there is no point staying here. So it has to go above than 11.5. Okay, so that's what it does. Okay, it basically goes above. This is 11.5, this is 12.5. And now you basically have new error. This is new best fit line. And then you have got new error. So let's say this is 2, this is 2.5, and this is 3.5. So what is the total error for this line? What is the total error? 8, correct? So total error here is 8. So now your model knows that, yeah, it needs to go above. Okay, so whatever the error you are getting, you actually need to go above. Okay, because if you're going downwards, you're going to get more error. If you're going above, you're getting reduced error. So this is what happens, like trial and error, trial and error. It continuously happens in such a way, and then finally you basically get the best fit approach. So this is the best fit approach where you're getting the error as 0.5, 0.5, and this is 1. So the total error here is 2 now. The total error of this line is basically 2. Okay, now what happens if it goes above, it's getting an error of 2.3. If it goes a little bit below, it's getting an error of 2.4. So it basically stays in here where it basically gets the minimal error, and this line is basically called as best fit line. Yeah, that is your best fit line, guys. So this is how a linear regression basically finds its optimal line by using a gradient descent function. There is a concept called as gradient descent. What I'll be walking you guys through it later on in the sessions. But as of now, you need to understand that whatever I have shown you right now is an example of gradient descent. I'm not going to get more details of gradient descent because it will confuse a little bit more. So I'm just trying to avoid that as of now. We'll get to know once we start working on this. Once we get familiar with other concepts, then I'll come back to this gradient descent concept once again. Okay, so this is how your linear regression basically works like. Okay, now if you proceed further, okay, now let's say if you want to find the optimal method, like at the back end, what exactly is it working there? How is it working there? So this is working in this pattern. Like this is your original point. Y2 is actually your original point, and Y2 hat is your predicted point. So all this, the way where line passes, right? If you take a parallel line above it, so there you would get your predicted points. So all of these points which I have marked in red is basically the predicted points, and the points in blue are the actual points. So how do you calculate the error? You just do this: yi minus yi hat, the whole square, summation of all the squares from 1 to n, whatever the number of data you have. Okay, so that is yi minus yi hat, the whole square summation. Okay, so yeah, again, this is independent variable, this is dependent variable. Anyway, so this is how we calculate at the back end. Now, there is another method where you can actually find out this best fit line by using this equation y is equal to mx plus c. So there is a formula, what I'm going to share it with you. So in that formula, if you basically calculate this data like m and c, that is slope and y-intercept, if you calculate the slope and y-intercept, you will get the actual best fit line. Yeah, you can get that best fit line. How? Let's look into it. Okay, so this is the equation of a linear line, y is equal to mx plus c. So where m is basically your slope of the line, okay, the slope of the line here, okay, and then c is basically y-intercept. What do you mean by y-intercept? That means from which point the line actually starts, like at what point of y the line starts. Okay, it can be 1, 2, 3, whatever it is. Let's say this is 3. So the line starts at 3. So here y-intercept will be called as 3. Okay. Yeah, when x is equal to 0. Exactly. Yes. Okay. So this is y is equal to mx plus c plus, and this one is y is equal to b naught plus b1x. So we have just rewritten this line in this form. Y is equal to b naught plus b1x. Okay, where b1 is basically the slope of a line and b naught is basically the y-intercept. Okay, b1 is basically the slope of the line and b naught is basically your y-intercept. Okay. Exactly the same thing. I've just renamed it. Okay, instead of mx plus c, I've renamed it as b naught plus b1x. Okay, so now we basically have to do some example. Okay, so I request every one of you to please take a paper and a pen. I mean, a notebook and a pen or a paper, whatever you have. Just grab it and draw this. Draw as in write these equations. I mean the values. X is equal to 1, 2, 3, 4, 5, and y is equal to 2, 4, 5, 4, 5 something. Let's say x is basically bhk. Let me change the color of my highlighter. I mean the pen. Yeah, x. This is bhk, and this is price of the house. Let's just assume. Okay, let's just assume this is bhk and this is price of the house, and this is 10 lakhs. Okay, the price is basically 10 lakhs. So wherever you have 2, that means 20 lakhs. Wherever you have 4, that means 40 lakhs. Okay, something like that. This is 50 lakhs, something like that. Okay, this is the data what we have. We don't have to cross verify the data because this is not the real data set, guys. We're just trying to assume how things work. Okay, so let's just proceed with the same data set. You don't have to worry about the data set here. Yeah, I'm assuming you guys are getting notes and pens, so that's why I was silent. So yeah, just note these points: 1, 2, 3, 4, 5, and 2, 4, 5, 4, 5. Let's proceed further, and let's draw this up. Draw this thing up. This is x value, this is y value. Then you need to find out x minus x bar, y minus y bar, x minus x bar the whole square, and x minus x bar into y minus y bar. So do this. Okay, so what is x bar, y bar? Have you guys calculated x bar and y bar? Yes, people. X bar, y bar. Have you calculated it? Let me know. Yes, x bar and y bar is nothing but it's mean of x and y. So now you guys calculate and let me know. Yes, Nayan, correct. Yes, it is nothing but 3 and 4. Okay, x bar and y bar is nothing but 3 and 4. Okay, guys, x bar is 3, y bar is 4. Okay, this is x bar and this is y bar, 3 and 4. Okay, the average values. Now calculate this for me. X minus x bar, that is 1 minus 3. Yeah, that has to be minus 2. So calculate the same for rest of the column. Yeah, give everything in a single line, guys. Otherwise, I won't understand which value you are giving. Give everything in the form of a list or a series. Okay, so your x minus x bar would look like this, correct? Minus 2, minus 1, 0, 1, 2. So similarly, you need to find out y minus y bar. Yes, so similarly calculate y minus y bar. Okay, so let me proceed further and let's cross verify with you guys whether you are getting the same values or not. Yes, so most of you guys have got the correct values, I believe. Okay, minus 2, 0, 1, 0, 1. Now, what is the next thing? X minus x bar the whole square. You don't even have to like take this value 1 minus 3. You don't have to do that again. Instead, what you can do is you already have x minus x bar. You just square this thing up. Like minus 2 square, that is 4. 1 square, 1, 0, 1. And then 2 square is 4. That is what you have. So if you calculate this up, 4, 1, 5, 5, 1, 6, 6, 4, 10. And then similarly, what is the value here? X minus x bar into y minus y bar. Minus 2 minus 2 is 4. Minus 1, 0 is 0. 0, 1 is 0. 0, 1 is 0. 2, 1 is 2. So if you calculate, what is the value you get? You get 6. You get 10 here. You get 6 here. So are you getting the same results? Yes. Anyone confused with the calculation? Please let me know. I believe everyone are clear with the calculations, right? Okay. Fine. So once we're done with this, guys, let's proceed further and let me explain you the formula what you have got here. Because that is not required, Amit. This is what the formula we have to calculate the slope v1. The formula is this: x minus x bar into y minus y bar divided by x minus x bar the whole square. This is what the data. I mean the formula what we have to calculate the slope. Okay. So how do we do this now? You already have the value, right? So this is 6 and this is 10. So what is the value of slope here? The value of slope is 0.6. Correct, the value of slope is 0.6. So there are various theories which actually explains this, like why b1 is equal to this formula. Okay, there are basically various notes where I have read this, and there are some derivations also. So if you're interested, let me know. I can just give you the link. You can go through the link. Okay, so yeah, if you're interested, I can add the link in your drive folder. You can actually go and cross verify. Okay, so how exactly it is working. Okay, so this is how it looks like. Okay, so b1 is equal to this one 0.6. So now if you look into the sentence here, guys, what we are going to do is to find the another value. Like we need to find b naught, right? B1 we have got the value as 0.6, but b naught we still didn't get. So to do this, what we do is we basically replace y with y bar and x with x bar. That is 4 and 3. Okay, so if I rewrite the equation, it's going to look like this. 4 is equal to what is b naught? B naught we don't have, but b1 we do. 0.6 into what is x? 3. So if you calculate b naught, what is the answer you're getting? Oh, no, quick enough. Good. Yes, guys, what is b naught? What is the y-intercept value we are getting? This is y, this is x. Yes, so y, sorry, b naught value what we are getting is 2.2. So if it is saying 2.2, then what happens? That means we are basically going to start from this point, and this is how our slope is going to look like. So this is our b1, that is slope, and this is b naught, that is 2.2. So my value will start from 2.2 here, and the slope, our main line or best fit line will have a slope of b1. So this is how you basically calculate the linear regression by using the least square method. This is basically called as least square method. So this is what we do. Okay, and then now you have received 2.2. Now, guys, what if I want to find out the price of 2.5 BHK? So can someone tell me what is the price of 2.5 BHK? Tell me. I want to know the price of 2.5 BHK. So can you guys find it out? If yes, then please let me know. What is the price of 2.5 BHK? I need to know the price of 2.5 BHK house. So on x-axis, you had the number of BHKs. On the y-axis, you had 10 lakhs. I mean, the price of house in 10 lakhs. So now you tell me what I'm giving x is equal to 2.5 BHK because this is our input, right? So I want to find out what is the price of the house with 2.5 BHK. So calculate it and let me know, guys. Yes, Kaushik, exactly. So how much would that be in 10 lakhs? Yes, Kaushik, how much is that going to be in 10 lakhs? Yes, Harshit, exactly. Yes, Uma Maheshwar, correct. Raunak, I think there is slight confusion in your equation. I mean, your answer is correct, but this is not the standard how you write it, okay? Either don't use comma, or if you use comma, then make sure you standardize it, okay? I mean, your answer is correct. I mean, I'm just giving you a general knowledge, okay? Free ka gyan, you know. Anyway, so the value here, what you're going to get is 3.7 lakhs. Oh, sorry, 3.7. That is, if you can multiply with 10 lakhs, it's going to be 37 lakhs. Okay. No, yeah. It's in 10 lakhs. That's not in 1 lakhs. It's in 10 lakhs. Okay. So we are just maintaining a price of, let's say, a very small city in India, a town. I cannot call it a city. Let's say a town in India, right? So with 2.5 BHK, we can get a house for 37 lakhs, right? So yeah, that's what I thought of, like doing this. Anyway, so you understood, right, guys, how exactly it worked. So this is what it did. Okay. So y is equal to 2.2 plus, because we have to find y. Here everything is known. We know what is b naught. We know what is b1, and we also knew what is x, because this is the value what we need to find out. So if you equate here, you are getting y is equal to 3.7. Okay. So this is how it looks like, guys. Okay. So now the next thing what we are going to do is we are basically going to do the exact same thing in our machine learning environment. Like by using our Python code and machine learning library, we are going to do the exact same problem, and we would expect the same output over there. Okay. So let's just proceed further. Okay, so let me just proceed further. So first of all, let me make a drive for you guys. You're batch 2, right? So let me go for the same batch. July Python. Oh, batch 1. Okay, fine. Versio July Python 1. Okay, I'll just rename this file. Okay, guys. I'll just rename this folder. I'll just rename it to Versio July ML 1. Okay, and I shall create a new folder here where I'll call this as Python, and I'll push all these files to this Python folder so that you guys doesn't get confused here. Okay, so all your Python is over here. I have been deleted it. Okay, now let me create a new folder here which we call ML. So whatever we have for ML, it will be added in this folder. Okay. Now talking about the data, guys, I want to give you the exact same data. Okay, whatever the data I have actually shown you right now, right? So X is equal to 1, 2, 3, 4, 5, this data set basically. Whatever the data set we have here, I'm going to give you the same data set so that it is easier for us to work with it, right? So I'm going to give you the same data set. The data set is called lsm1.csv. So just load the data set, guys, lsm1.csv. So, okay, not Google. I want to open a Colab notebook, a new notebook. I'm going to call it as lsm1. Connect it, load the data. So I loaded the data set here. Locate the data and let me give you the link of this. So if any one of you doesn't have the link of this folder, guys, let me give it to you right away, because I think there are some people those who are actually not present in our session for Python. So let me share this link again so that there is no confusion. Yes, so this is the drive link, guys, what you are going to use. So move to what's your July, right? What's your July ML1 ML? Move here, move. So that is done. LSM file have been moved here. Okay, inside the ML folder, yeah, you're gonna get this LSM file. Okay, so that's done. Copy the path. So first of all, pandas, right? Load the data. That is what we need to do. So df is equal to pd.read underscore csv, and yeah, this is the path, data frame. There you go. So this is the data frame what you have. Please let me know once you are done with this. Okay, I'll be back within a minute. Okay, just do this thing and let me know if you have any difficulties until here. Okay. LSM file is not appearing in a data folder. Why is it? Did you refresh it once? Just refresh it once and check whether it's coming up or not. Okay, are you able to see the file here? Please tell me that first of all. Okay, you can. Okay, fine. So just download this file to your computer and then click on this folder option and then add the file from your computer to here, upload to session storage. Then select your LSM file and then hit on open. Okay, and okay, you guys must be wondering about this location, right? So this location, I received it from here. Just click on these three dots, copy path. Click on these three dots and then you just click on copy path. Okay. So this is what the data frame looks like. Now I'm going to go back to that PPT, what I was actually explaining it to you. Okay, where is that PPT now? Dheeraj, I was just saying you have to open on this files option, load the data file, whatever you have downloaded to your computer from here. I have asked you to download this file from here. Okay, just download the file to your computer. And then once it's done, click on this file option in your Google Colab, click on this button, upload to session storage, and then select your file from the option, whatever you have, hit on open. The file will be added here. Once the file is added, click on the three dots, copy path, and then paste your path over here. Okay. Yeah, I just wanted to show you. Okay, not this one. Sorry. Yeah, I just wanted to show you this stuff. No, not this. Yeah, machine learning steps. So what are the steps here? Anushka, okay, you're not able to open any file. Okay, Anushka, I'll ask you to share the screen once you're done with the session, and then I'll help you there. Okay. Are you able to open the Google Drive first of all? Can you see the files in Google Drive? Yeah, just download those files, then I'll tell you what to do next. Okay. Fine. So machine learning steps. The first thing is take the data. So we have done that step already. Like we have already loaded our data into our environment, what we are going to work with. Okay. The second thing is filter the data. We basically have to filter the data now. Filter the data as in we have to clean the data. Like if you have any missing values, or if you see any outliers in the data, if you see some irrelevant information in the data, we basically clean that, right? But as of now, it's a very basic stuff. So we are not going to do that. We are just going to leave it as it is. Now comes the most important part, guys. Divide it into input and output variable. So we basically have to divide it into input and output variable, the third option. That is what we need to do here, right? So how do you divide it into input and output, guys? You basically give a variable as x, and we consider x as an input. Okay, this is denotion, guys. Denotion, that's it. Notation. Okay, there is nothing else apart from notation. X is basically the notation. Okay, guys, we don't have anything else. Okay, x is basically just a notation. So x is equal to df dot iloc. Okay, df dot iloc. So what do I need? I need the first row, first column and all the rows, right? So in iloc operator, we usually target the complete rows first, and then we basically target the columns, right? So first 0 to last rows. So that's why I haven't given any data there. And if you're talking about the row, which row is it? That's 0, right? So we write dot values. Otherwise, the data would be in data frame. I don't need the data in data frame, but I need it as a list. Okay. Or you can also keep it as it is. It's completely okay, guys. There's no difference in there. Okay. So let's proceed further. And this is x. So similarly, how you have figured out the x value. Oh, sorry. Yeah, you need to figure out the y value as well. The only change you need to do is instead of 0, it will be 1. You can cross verify once. This is how your x looks like, and this is how your y looks like. Now, yeah, guys, sorry about that. I told you that it would be in list, right? No, it's not in list. It's in a numpy array. If you check the type of x, it would basically say it's an n dimension array or a numpy array. Okay, so this is useful actually. So x dot type. Okay, you have to write type of x. Sorry. Yeah, it's basically numpy dot nd array. Okay, correct. No issues. So here we have got x and y. So we have divided our input and output. What is the next thing? Input and output is done. What is the next thing? We need to divide the data in train and test variable. So we don't have that much enough of data to train and test. So whenever we are training the data, right, training and testing, we actually require some huge amount of data, but we don't have that much amount of data with us. So we are going to skip this step. Okay, we are not going to go with fourth step. Even the fifth step. Fifth step says normalize the data, like make the data in the same standard, in the same format. In the data, whatever we have right now, it's already in the same manner, like it's standardized. Already it's in the standard form, right? So in the same form, in the same format. So you don't have to do standardization as well. So we can also skip this standardization part. Okay, that is fifth part. Now run a classifier or a regressor. Now, guys, to run a classifier or a regressor, so what do we need here, guys? It's a problem. It's a regression problem, right? So to understand this regression problem, what we need to do is we basically have to go for the most famous machine learning library called as sklearn. So just go to this sklearn library, search for sklearn. Okay, if you are not able to search, then this is the link. You can just click on this. So this is the sklearn library where we actually proceed further with our different types of approaches. So the one what we are interested right now is regression. So just click on regression, and what are the regression we are working on? This one, ordinary least square, right? Supervised learning, ordinary least square, that is linear models basically. So this is the one what we are looking for. Okay, ordinary least square methods, right? So least square method. So this is what we need to do. So from this library here, there is a library for your linear regression. We have to use this library. Okay, so you can just click on linear regression example, and you can understand how exactly it has been done. Okay, so to do that, guys, first of all, we need to import our linear regression, right? So how to import that? It's given over here. So from sklearn, we need to import linear model, and from linear model, you have to import linear regression. Okay, so that is one way how to write this thing down. For me, I'll write it in another way. Okay, I mean, it's the same thing, no difference. So what I'm going to do is I'm going to write from sklearn dot linear model. Okay, instead of importing linear model and then importing linear regression later, I'm importing linear regression right over here. That's the difference. That's it. It's basically the same thing, guys. It's just a different way to call the class. Okay, at the end of the day, we need linear regression class. Sorry about that. Yeah. So as I told you, at the end, we just need linear regression class. That's it. We don't need anything else. Okay. Now, once we have imported linear regression class, we need to create an instance of this class and save it to the object. Okay. To perform our other steps, we cannot directly do it on the library. We have to create an instance of that class, right? So to do that, I'll call a new variable called linear regression. Sorry, lin. and I'll call this class now and give the parenthesis because we are creating an instance of this class, right? It's an object now. Now your lin is basically an object. It's not a class. So we can basically take the various functions out of this class now, right? So just run this up. So there you have lin. And now what you need to do is we have to train our model, right? We have to do a training model here. We have to train our model. We have to give our x and y values. So to do that, we have a function called as lin.fit. We have a .fit function where you have to pass the parameter x and y. There you go. So this is basically your x and y. Okay, there's an error here. What is that error? Expected 2D array got 1D array. So your input, guys, according to this fit method, your x. Yes, Mohammed Hassan, I'll do that. I'll do that. I actually forgot to give you this file, I believe. No, I've already given you. Yeah, Mohammed Hassan. Just open this up. Okay, you have a file over here, right? Inside ML. Just open this up. You will exactly get the same file, whatever I'm doing here. Okay. Fine then. So now, guys, we have got this error. Line number, okay, whatever the line number is. Line.fit. Basically, we have got this error. We are saying x has to be 2D array. Why? I'll explain you later. But now we have to reshape this. Our x, whatever x we have, we basically have to reshape this. No. Okay, Medhanand, I'll explain that. First, concentrate here. I'm reshaping it into what are the values? 5,1, right? Yeah, I'm reshaping x into y,1. We don't have to reshape y. Y would stay as it is, no problem. And now if you do a training here, it is done. Everything is fine. And finally, what you do is you go with predict function. So lin.predict and x is to be in 2D, right? So what was the x we were checking out? 2.5. So the value of x was 2.5, lin.predict of 2.5. So run this thing up and there you go. So you are getting the exact same results there, 3.7. Okay. So this is how your linear regression basically works. Okay, now you are asking me what is this sklearn.linear model? See guys, in Google Colaboratory, I've already answered you, right? This library is already installed. So we don't have to write pip install in sklearn. But if you are using Jupyter Notebook or any other IDE apart from Google Colaboratory, you need to write pip install sklearn, install the sklearn library properly. And then you basically, from sklearn is a very huge package. Okay, and from sklearn, you basically target linear model module. This is a module. And from this module, we are getting this class, linear regression. This is what we have done over here. Okay. So that's all for today, guys. So this is what this is how we basically solve a linear regression machine learning model. So this is a very basic thing, guys. I have to explain a lot of stuff even with this. So we don't have time for that. So now, right, so maybe we'll start it in the next session. Don't worry. Not maybe, definitely. I'll explain you all the components, whatever we have done again once more in the next session. Okay. So don't worry. Okay, first try to do this and just check whether it's working or not. And then in the next session, I'll explain you in much more detailed manner. Okay. So don't worry, guys. This is what we do. Okay. Okay, why did I reshape? I reshaped because I got an error. The moment when I'm giving x, if x I'm passing it as a one-dimension array, I'm getting an error. So the requirement here is in the fit function, your x value should be in 2D array minimum. So that is the reason why I have reshaped it into 2D array. Okay, so I've already given you the file, guys. You can go through it, work with it, and then let me know if you have any issues. Okay, so if you have any concerns, any issues, please let me know. And who was that having a problem with the MacBook? Yeah, whoever wants, just share your screen. I'll just go through that. Okay. 5,1 is the shape, Yash. Earlier, the shape of the dimension was 5, nothing because it was just a single dimension. Now I have created 5,1, that is 2 dimension. That's it, nothing else. Okay, Yash. Yes, Ronak, you can also do that. I'll show you in the next session how to do that. Okay. Sure, Raj. Definitely, I'll explain the whole thing in the next session because today we are getting late, right? So I just wanted to complete this. I've completed this. If you have any concerns, you can ask me in the next session. I'll definitely help you in the next session, so you don't have to worry about it. Okay. I'll definitely revise everything whatever we have done in this session. Don't worry. Just relax. Chillax, guys. I'm there for you. Don't worry. We'll do it in the next session. Okay. Fine then, guys. Thank you. Thank you so much. We'll see you in the next session then. Okay. Bye-bye, guys. Thank you. Thank you so much. Bye-bye, everyone. Take care. Good night. Bye-bye. Yes, Raj, please ask me. It's okay. You can ask me. Thanks, Mohammed Hassan. Thank you. You too. Take care. Everyone, please take care of yourself, guys, and get vaccinated as whenever it's possible to get it done. Just do that thing as soon as possible. Yes, Raj, I'm actually waiting for your question. So. Those dots are your data points, Lokesh, depending on your x and y values. Okay. This means, Naveen, all the rows and only 0th column. That's what it means by. First set of entries for all the rows and the last one is for the columns. I've explained this in Pandas classes, right? Okay, what are the other topics that have to be well aware of maths and statistics that is important for ML and AI stuff? A little bit of linear equations, Raj, and then a basic concepts of derivatives. That is fine enough. And if you're talking about statistics, then basic statistics is enough. Until in my sessions, basic statistics is enough. But if you are going further, then yeah, you need to know a bit more. Okay, I'll give you the list. What are the statistical methods you need to know? I mean, hypothesis testing and all, whatever the hypothesis testing I've shown you, right? So if you know that, then it's enough. Okay, that should be fine enough. Like what exactly is hypothesis testing? What is t-square test? And then what is AB square? Those steps, whatever the methodologies you have to do the hypothesis test. Then there is again z-score testing. So yeah, that should be it. Okay. ठीक है राज, करेंगे अपन, ठीक है. I'll give you the list, the concept what is required for further classes. You can just go through it. Okay? Fine then. Thank you guys. Thank you so much. We'll see you the next session then. Bye bye guys. Take care everyone. Thank you. Thank you so much. Bye bye.